Well, I'm sure some people are going to kind of keep floating in a little bit, but I'll start doing a bit of the spiel. Welcome to Cleveland React. Um, I was I was starting to look through to see who was first timers or not. I'm pretty sure Nick was his first time you've made it. But anyway, welcome to anybody who hasn't been before. We started this a year and a couple months ago. What was it, like June or something of 2019? And it was actually Zach's whole idea, and I kind of like tagged along. So we've been kind of going strong. I mean, we took a little bit of a break here in the summer, but I'm happy to kind of get going again. We have we have the Slack. This stuff is always hard with the chat because anything that I drop into chat, nobody that like checks in after will be able to see, which is always really annoying. But we have our Slack, we have a Cleveland React room in the Cleveland Tech Slack that we try to use for posting resources and stuff like that related to the talk. And so I'll keep an eye on the Zoom chat, but in general, I'm going to post a link to the here we go. I'm going to post a link to the our tech Slack here in our Zoom chat, and then if people kind of want to wander over there to get some of the chat stuff, we post links. If you feel more comfortable asking questions there, we'll try to keep an eye on that area too. I'll watch out for the Zoom chat, but if you are able, if you have Slack, that's going to be kind of the place to go. We have a let me find this. We have a code of conduct that we appreciate if everybody sort of abides by, and the full text of which is linked on our meetup and on clereact.dev. But the general gist is Cleveland React, is a safe and friendly place for all people, and we do not tolerate behavior that makes people unsafe, that makes people feel unsafe. And so if anybody either experiences or witnesses anything like this, please reach out. You can reach out on Slack, direct messages. You can email us at hello@Cleveland React or hello@clereact.dev, and Twitter, meetup, direct message, anything like that. So please just feel free to reach out to us if you have any questions or concerns. As always, we're looking for speakers to talk or to, if you have ideas for events, we'd love to hear them. We did a poll, which I think a lot of people, filled out a while ago and got some kind of cool insights. The sort of testing, the ideas for some testing events came from that. There was a lot of people wanting to learn more. So thank you to everybody who filled out that survey a while ago. I appreciate it. And we're all trying to kind of figure things out as we go. But if anybody has any specific ideas for things they would either like to learn about or like to present about or join a panel or something like that, anything like that, we're always open to here, and we're always looking for events. So please keep us in mind if you feel like that, and we would be happy to help work on it. Work on a talk if you want to do a talk, anything like that. We can workshop some stuff like that too. Let's see here. Does anybody have any events coming up? I was gonna talk a little bit about Hacktoberfest, which is coming up too. But before I dig into that, does anybody else have any cool events or anything coming up that they'd like to share with the group? Please, I think I'm gonna check here. Well, please let me know if if you do. We can post it in the Slack room too if you think of something later, and I would be happy to share that. I mentioned Hacktoberfest. This is here, I'm going to share this real quick. This is an event coming up that a company called DigitalOcean runs, and it's called Hacktoberfest. And so they do this every year. I'm not sure how many years I don't know if it says here. I don't know how many years they've been doing it, but it's been going on for a while. And the idea for Hacktoberfest is to get more people involved in open source. And so they run this event where if you sign up and if you complete, like if you submit 4 pull requests, basically you have completed Hacktoberfest. And they have a very large amount of t-shirts that they're sending out to people who do it. It's not like unlimited, but I think it's, I don't know, I forget what it is, 20,000 or something, 17,000 or something like that. So, you know, it's like a big like a good chance you could get a t-shirt if you participate. And I don't know, it's a cool event. So I've been kind of getting involved in it in some other areas, but I don't have anything specific for Cleveland React today, but I wanted to put it in front of everybody. And if anybody is interested in participating, but would like some, I'm going to put this in the Slack too, would like some help or some guidance or anything like that, please reach out. Either privately to me would be fine, or in the Cleveland React room, or any other Cleveland Tech Slack channel. I know there would be people other than me, but including me, that would be happy to help if you want to learn more. Nick, you have a talk coming up about Hacktoberfest. I can't remember if that was coming up or if it was in the past.
Yeah, no, it's I did a short talk, which was kind of preview of it, but I'll be giving a talk on October 1st on the DigitalOcean Community Tech Talks. I'll post it in the Slack there. You can't hear me?
No, I said, is that going to be here? I'm sorry, I was looking.
Oh, yeah.
I was just going to see if it was in the events.
Okay. Yeah,
no,
I mean,
it's like meetups or something.
It's kind of hard to find the talks on DigitalOcean. They have it under tech tutorials for some reason, but which channel should I post it into?
There's a Cleveland React channel here that'll.
Well, I'm in the Slack, but there's like only 3 channels. There's announcements, intro, and random, I think.
Oh, you probably just have to.
Those are the defaults.
Oh, okay, I got to join. Sorry.
Yeah.
That's me just completely forgetting that I have to join another Slack in that. So.
Yeah. Here you go. I'll just get you. There we go.
Cool.
Yes, there's a lot of channels, and so we don't choose to assume that everybody wants to be in all of them. But yeah, that'll be cool. So I'm sorry, Nick, the event here is going to be sort of getting the most out of open source. This will be cool. So if anybody is interested in digging into open source a little bit more, I think this will be a good talk. And there's a whole lot of community out there that's like excited about Hacktoberfest. So a lot of resources, and we'd be down to help people get involved if they would like. So that is Hacktoberfest. I'm not sure if I have any other notes. John, do you have anything to add before we kind of?
Nothing. I'm sure there's always like digital conferences floating around, but I can't think of anything off the top of my head.
Yeah, there's a few, but I think there's like MS Ignite, but I don't know if I don't think it's web dev specific. It's like it's Azure, and I think it's just like everything Microsoft. But and then there's another one. Oh yeah, there's if anybody's interested in Next.js, they are having a conference. I gotta find it in our virtual coffee Slack there, Dan, but I forget when it is. I'm pretty sure it's in October, but it's free tickets to a Vercel event. I think they've got already like 20,000 people registered or something. It's pretty insane. So
Nice. Well, I'll track the link down for that while after we get Zach started, and we will post it in the Slack room as well. So I think we'll just get started. Zach, I mentioned at the beginning, but Zach is sort of the founder of all of the Cleveland React meetup. So, and then almost immediately moved to St. Louis. But we are still very appreciative that he got all this going for us. Zach is a director of software engineering. Is that right, Zach? At AHA, and does a lot of Ruby and a lot of React and stuff like that. And he's going to run us through React testing library. So thank you, Zach, and take it away.
Thanks. Yeah, thanks for coming to my talk. Let me share this to start with. So usually people get to the end of the talk and then they're like, here's the GitHub. I'm just going to post the GitHub up front. I've put kind of the TLDR of the speaking portion of the talk in the README so you can reference it later, just the information and thoughts I'm going to share. And then after that, we're going to dive into some live coding and actually write some tests, because I think especially with testing, it's easier to see it done, kind of get some experience for the feel of it, and then that'll hopefully give you some takeaways to help your own testing. I just posted the link in the Slack for this GitHub in case you want to follow along on text or reading text, that is a word. So React Testing Library is a testing library for React, as the name suggests. I think the name is my least favorite thing about it because it makes it frustratingly hard to Google anything about it, but the library itself is fantastic. It is, I believe, the officially recommended quote unquote React testing library. If you look at the React.js docs, they suggest you look into it, that sort of thing. And it's really, I think, improved a lot of how I write tests, at least some of the philosophical notes here. A couple of caveats before I get into the talk. First and foremost, tests are good no matter how they're written or what kind of tests they are. At AHA, certainly our code base has hundreds of tests that don't follow the practices that I'm about to describe. And many of them I unfortunately wrote in a past life before I learned more about testing. Generally speaking, we've adopted React testing library for all of our new tests. We've tried to kind of spread some knowledge internally about good testing patterns and more importantly, why they're good testing patterns. But I don't want you to go away from this talk feeling like the tests that you've written over the last months, years, whatever, have been a waste, or that you should go and rewrite them or anything like that. I think tests are valuable in and of themselves. And secondarily, enzyme. If you don't know what enzyme is, don't worry about it. It's not really important for this talk. It's just another option that a lot of folks used prior to React testing library. But it is a fantastic tool, and it was the gold standard for JavaScript testing for quite a long amount of time. I'm going to have some critical opinions of enzyme, but you should read them in the vein of, enzyme gave us a lot. I'm grateful to it. I think it's a great library. The folks who work on it have done fantastic work, but also we've learned from it and kind of evolved into some better patterns, or patterns at least that I personally think are better, which is kind of the basis of the talk. So with that said, first and foremost, how does React testing library actually work? So what's going on under the hood? It's relatively simple, especially compared to enzyme. The complexity of the code is very simple. So it basically just renders your component into JS DOM. So you can imagine, instead of loading your component in a browser and it renders, it's just loaded in a headless browser that's a DOM implementation in JavaScript. And then it just gives you a set of relatively simple helpers to help you interact with the DOM. So get an element by text, get an element by its label if it's an input. You can type, you can click, basically the kind of range of ways that a user might interact with a browser. And that's kind of all there is to it. So it's intentionally simple. There's not a whole lot of mocking or interfaces, wrappers, things like that. You can basically think about it as just a DOM under the hood, and then the events you're giving it as something that someone would do to a DOM by clicking or typing or whatever. And that mental model will serve you pretty well throughout the talk. There's a couple of kind of guiding principles which are kind of lifted from React Testing Library's website, also Kent C. Dodd's Twitter account. Kent C. Dodds is a React developer who wrote React Testing Library and is relatively well known in the community, has a lot of thoughts about testing. And I think it's helpful to know kind of the philosophy behind it ahead of time, because that'll maybe guide insight into some of the decisions we make when we actually get into writing the tests. The first one is test your code the way that a user would use your code. And so the quote there I've lifted directly from the site, the more your tests resemble the way your software is used, the more confidence they can give you. So what that means is that you should try to give inputs to your tests that are the things that a user would do when they're interacting with your component, which are things like clicking, typing, scrolling, keyboard events, other interactions like that. Users don't care what methods your component has, if it has methods at all, if it's class-based or functional. They just interact with it kind of externally with the browser as the intermediary. And so if you think of your tests that way, it tends to produce fairly robust tests that aren't brittle, because as long as the component keeps appearing the same way to the end user, then the test will continue to pass. And that's kind of the philosophy behind reacting testing library. So I mentioned it's simpler in comparison to Enzyme. Part of that is it has way less functionality. It lets you do a lot less, but that's kind of intentional because the things it does let you do tend to result in better tests. So if you imagine I have this class-based component here, very simple contrived example, but I have like a button, and when you click it, it clicks on some kind of complicated method that we want to test. With Enzyme, it's pretty easy to kind of get a handle on the component instance itself. So I can render my component and then just call the method directly. And the example is a bit contrived, but it's a pattern that becomes tempting as your component increases in complexity. If there's a complex chain of actions that has to happen for the complicated thing method to fire or something like that, then it becomes really tempting to just invoke the method and then test the method, and you can get the coverage lines up in your coverage report and whatever. But it doesn't result in a good test, or it results in a test that's suboptimal, I should say, for a couple of reasons. The first is that imagine that I want to refactor this component and I want to use React hooks, or really any other refactoring. It doesn't matter a bunch. Maybe I want to keep it a class component, but rename some of the methods, move the methods around. The behavior should be the same from the user's perspective. And especially when I'm refactoring, I really want my test to give me confidence that I've kept the behavior the same, that the user isn't going to see anything different. But I have to completely rewrite my test if I've written it this way, because it knows about the existence of this method within my component, which is what we call an implementation detail. It just means it's a detail within your component, like a method name, a variable name, whether it's class-based or functional, something that matters within the component, but doesn't really matter to anything in the world outside of the component. That also reduces some of my confidence, because if I have to rewrite the test while I'm also refactoring the component, refactoring components and tests at the same time means you're more likely to miss things, because you refactor the component and then you're rewriting the test so it passes. And once you get the test passes, you're usually like, sweet, the test is good now, but maybe the test isn't testing the same thing anymore, or it's missing a case or whatever. The second reason why this sort of pattern is suboptimal is that it doesn't cover the full surface of the code. So it skips the interaction between the user clicking the button and then the method actually being called, which is relatively simple, but maybe there's something in there though that could introduce bugs. Maybe I put the wrong function in there so that, I click the add button and it's actually a delete button or something like that. If I was just invoking the method directly, then the test would pass, but the behavior would be wrong from the user's perspective, and I wouldn't be able to catch those kinds of bugs as easily. The second principle is test your code with a real DOM. So it's sort of hand in hand with the first one, where Enzyme, you can easily get component instances, which is like the JavaScript class instance that is your component. React Testing Library only gives you DOM nodes. So the nodes you can get access to are pretty much the same as what you would get if you went in your browser and typed document.getElementById or something like that. It's kind of an extension of the first principle. So your user is going to experience your component rendered in the browser via a real DOM. So your test should be as close to that as possible, which is good for a couple of reasons. It's good because it's future-proof. So React hooks, for example, didn't work in Enzyme for quite some time after they were released, because Enzyme kind of mocks everything, gives you mock wrapper instances, and then they had to go and rewrite a lot of the library to support the new hooks API. Obviously, React hooks worked in the browser from day one because they're just JavaScript that browsers can run. And so with React Testing Library, next time the React team introduces suspense or other cool things like that, it's just going to work. You don't have to wait for the Enzyme team or whatever to get around to implementing the new stuff. Sometimes you run across a browser API that's not supported in JS DOM or something like that. But it's pretty easy to fix, usually by importing a polyfill. And that can also be a helpful reminder in itself, because your users are probably going to hit the same thing if they go to your site from IE 11 or Safari 11 or whatever old browser people come up with these days. The second reason why testing with a real DOM is beneficial is just that it reduces the number of layers under test. So if you have a simple DOM-based test, the bugs can come from either React is rendering something wrong, which is pretty unlikely because React obviously is a widely used, well-tested library, or it's coming from your code. With a wrapper interface, there's a ton of ways in which the interface can not exactly correctly mock out the underlying behavior. And it's not super common that this happens, but if you get into a test that's failing from some weird internal enzyme thing that you don't understand, it usually takes a long time to debug, and it's usually some of the most frustrating debugging because you're digging through code that isn't yours and isn't even the framework's. The third note is that both of the above principles tend to result in better accessibility for the component as your end user experiences it. So the React testing library helpers that it gives you really by intention only work well if your code is accessible to screen readers, visually impaired users, other things like that. For example, if you have an input and the input doesn't have a label, it's really hard to get a handle on it to type into it with React testing library. And so it aligns the incentives so that you're driven to make your code more accessible in order to make it something that you can test, which is kind of a virtuous cycle of, resulting in two good outcomes. Enzyme, for example, is a lot more powerful. So you can use like class selectors, ID selectors, any number of ways to reach into the DOM and get a handle on things. But then also, you can end up with components that are less accessible because visually impaired users and that sort of thing obviously aren't using like ID selectors and class selectors to get the DOM node that they need to type into. They're relying on their screen reader to read the properly labeled component to them. And then there's a link there to further reading, which is just a link to the testing library docs, which some of this is lifted from. The second section here is, well, I guess I'll pause if there's any questions or comments or input before I keep on rolling through. Nope, we're good. All right. So the second section here is what I classified as Zach's opinions. So, the first section is pretty much what the React testing library docs and or authors will tell you about React testing library. So it's quote unquote official to the extent that anything is official on the internet. This section is more of my own opinions, which are derived from experience working with the framework, but obviously take them with some amounts of grains of salt, depending on, what you think of them. And there's two of them I noted here. The first one is to limit mocking to external boundaries. And so what I mean by that is when you're using any kind of real React component, you quickly will encounter things that you have to mock where your component interacts with the browser in some way, interacts with the outside world in some way. And your test will fail if you just run it in the abstract because your component is running in isolation instead of as part of your whole application. It's sometimes easy to get a little bit too far into mocking things because then you don't have to provide as many props if you're mocking out subcomponents, or you don't have to deal with weird browser behaviors or whatever. But generally speaking, I found that you're best if you try to mock the boundaries that are how your component interacts with the outside world, which are generally just two of them, the network and browser events. So in the network, obviously your component might have API calls, or it might have like GraphQL queries, depending on what you're using to fetch data. And React testing library tests are usually run via Jest or another test runner like that, where they're kind of in isolation. The API that they're talking to may not be running, or you don't want your test to talk to production. And so it's helpful there to mock out the network request that is being sent and then return the correct response, and then your component can happily move forward with that. And then obviously browser events. So the way your user experiences your component through a browser via clicks, typing, and that sort of thing are good ways to exercise the functionality. There are other ways you can reach farther into your component and mock things even with React testing library and kind of the behaviors it encourages. But if you can keep it to browser events and networking, then you're almost always better off for it in terms of the robustness and the stability of the test over time. The second thing I've learned painfully over time is avoiding snapshot tests for the most part. They're not evil. If we have plenty of them, like they do what they're supposed to do, they certainly help you ensure that your components are reproducing reliably. A snapshot test is just a test that captures the state of the DOM after your component renders. It writes it out to a file. And then when you run your test again, it compares the rendering of the component to that file, which basically guarantees that it's rendering out exactly the same HTML that it was the first time you ran the test and captured the snapshot. They're pretty quick to write because you can just call like expect container to match snapshot, and then that's it. Just does all the other magic for you. But I've found that in almost all cases, you end up being better off writing a more bespoke test for a couple of reasons. One is that snapshot tests tend to be fairly brittle. So if any minor detail of your component changes, like a class name, or you add a span somewhere or whatever, the snapshot test is going to change and you'll have to rewrite the snapshot, which means that your tests are churning constantly whenever you make legitimate changes to what the component is rendering. And it also kind of hurts your confidence somewhat in the behavior of or that your test suite is validating existing behavior, because you kind of get in the habit of running yarn test -u all the time to update your snapshots. And then you don't you're less confident of when you're updating things that you expected to change versus what you don't expect to change, which is kind of the second point, that it's easy for mistakes to slip through. So you update your snapshots, and the theory is that you'll push up your pull request with the new snapshots, and then one of your colleagues will carefully review each snapshot in the diff to see what changed and make sure the HTML is accurate, which is a nice idea, but in practice, it's very tedious reading through a bunch of snapshots of HTML. People don't do it or don't do it thoroughly. It's really easy to have tests that happily check in a broken behavior because they produce invalid HTML, or not invalid, but the wrong HTML. And nobody caught it because it's tedious reading through hundreds of lines of snapshots in a pull request. Whereas if your test is a little more focused on what it specifically wants to test, like type in an input, click this button, expect this thing to be on the screen, that tends to produce tests that if they break, then they're broken for real. And if they don't break, then you can be pretty confident that everything's still the same. So those are some of the kind of background philosophy principles that we're going to use. The next portion, we're just going to dive in and write some tests and see how it's done. I have this simple React. Oh, were you raising your hand, John, or just?
Yeah, but I can wait too.
Oh, go for it. Yeah.
So I know this boundary gets blurred all the time, and I don't think that's necessarily a bad thing. But when you're thinking about React testing library, is that sort of semi like integration type of tests kind of thing, like user interaction? So like your complicated thing would potentially be brought out into something that you would maybe unit test against and make sure that that piece does what it needs to do, but the whole like how it smashes in with all of your components and the user actually integrates with calling certain things or whatever. Maybe that's kind of like a more, I don't know, a little bit higher than like run the test fast, check the specific thing kind of level.
So I think that I definitely do think of React testing library tests as integration tests, where you're kind of rendering a component or multiple components fully out into a browser. You're clicking, typing, making expectations about the result, kind of a classic integration test. The sort of difference compared to maybe Rails testing or more traditional like the testing pyramid is I tend to find that unit tests aren't really all that necessary when you have React testing library integration tests. And I say that with a caveat. So if I have a component with some complicated logic and it's like a function that takes 3 inputs and it might have 5 different outputs depending on a bunch of logic, in that case, I'll almost always break it out into a helper file, and then I'll write just a plain just test that gives the function inputs, expects it to have outputs. And those can be really effective unit tests, obviously, just to make sure that your helpers are doing what you think they're going to. But in theory, at least, if you can exercise your component in all of the ways that a user would exercise your component by clicking, typing, etc., then you're in theory covering all of the cases that a unit test would cover anyway, but you're doing it in a way that is closer to what the user is going to experience in the browser, and also is less brittle if you refactor kind of the internal workings of your component in some way.
Cool, thank you.
Yeah, any other questions before I keep going?
I was just gonna say, I definitely agree with you on snapshot tests, because we're using Preact, but we migrated to Preact testing library, and I nuked all the snapshot tests except for we're also building out a design system, and that's the only place where I kept some snapshot tests, because the components, like the reusable components like buttons and like whatever like base controls you have, I think there it feels valid to check the markup there, but like elsewhere it's because as soon as you change a base component somewhere, every test that was using it that had a snapshot all fail. so that's why we scrap them, but we keep it for basically design system stuff.
Yeah, I definitely agree with that. I think snapshot tests do have some place, especially the closer to the leave your component is. If it's a simple, like takes 2 props and it might be red, yellow, or green, depending on the props or those sorts of things, I think that can be more valuable. those tend to be better because also they tend to produce less markup. Like if it's a button in a design system, the output is, 3 lines of HTML or whatever. So those tend to be more useful and easier to validate. It's just that you also have to be vigilant or else that creeps up into, the component that uses the button uses a snapshot and then you're kind of back to where you were.
Yeah, exactly.
Cool. So writing tests. So I have this to-do list app in React. It might look familiar if you came to my last testing talk a year ago. We're going to write even more tests though. So it does the things a to-do list app ought to do. You can check the box to check off the to-dos. I can add a new to-do, write some more tests, and I'll assign it to Jack. Do that. Pretty straightforward, not a ton happening there, but enough to give us something to play with in our tests. Let me switch what I'm sharing. So I'm going to try sharing my whole desktop so that you can see both the terminal and the editor, and you'll have to tell me if this is like visible text-wise or if I need to switch to just sharing windows. I see some thumbs up from John. Feel free to holler at me if you need me to make the text bigger or if it's not working for you.
Terminal can probably go up a little bit, but the editor's good.
Okay, cool. And there's all of the Zoom windows that were hiding behind the screen I was looking at. All right, glad no one's been sending me chat messages because I wouldn't have seen them. So this is, we'll start with kind of the simple component structure of the to-do list app. So it starts with the, sorry, one sec, Zoom has this bar that's just right in the middle of my editor. There we go. So it starts with just an app that has a header and then renders a to-do list. The to-do list, when it mounts, it fetches from an API to-dos and users. The API is just a simple library that serves an API from a JSON file, basically. And then sets the state to loaded, stores the to-dos and users. If we add a new to-do, we want to add it to our to-do list. If we update a to-do, we find the one we update it, and set the state. And then rendering, if we're not loaded, we render a simple loading message. If we are loaded, then we map over our to-dos, render a to-do for each one. And then at the bottom, we render this add to-do form in case we want to add some additional to-dos. To-do.js is the to-do kind of element or row or whatever. So it receives the to-do, the list of users, so it can find its assignee, and then a callback for when it gets updated, so it can update the state of its parent to-do list with the new value. So that's what update checkbox does. We're calling our API to update the state of the to-do with the new status, complete or incomplete, and then calling back to our parent. And then rendering, if it's complete, we use a FA reg check square. If it's incomplete, we use an FA reg square. When you click on it, we update them. And then just title and assignee. And then the add to do form, it's an add function that we use to add one. So it's create a payload for our API, post it, add the to do to our parent. And be clear, just clearing out the form state for when we want to add the next to do. If we're adding, then we render this form with some fairly standard just inputs, setting the state when things change, select box to select the user that's assigned to the to-do, and an add button and a cancel button. And then if we're not in the adding state, we show the blue add to-do button there that we can click to transition into the adding state. So we'll start with the add to do test, just because that seems like the simplest thing to test a form. I have a very basic test here that's not going to be particularly useful yet. So the couple of things to know about interactions with React testing library. The render function is how it's kind of the window into everything with React testing library. So almost all of your tests will start out with rendering a component. It returns an object, which is spreadable, and it will give you the container, which is just a DOM node that has your element in it as rendered in a browser. And then it'll give you a bunch of other helpers as well. So there's get by text, which finds an element based on the text that's in it. Get by label text, which finds like a form input or something like that based on the label it has. There's about 20 or 25 of these. If you Google React testing library cheat sheet, you can find a whole list. Get by text and get by label text are like 75% of the tests I write. So we'll stick with those two for now to avoid overcomplicating too much. So if we think about what we're doing with this component, we need to give it a list of users, and we need to give it a function that can be called when a new to-do is added. And so let's give our test a more useful name. Let's do that. Just.fn just gives you kind of a dummy function, so it can be called and won't throw an error like if you didn't have a function at all. And then later you can make expectations that, like, yes, this function was actually called. And then for users, let's just those Schneider. John can be our other user. So we've rendered our form. The first thing we want to do is click on this button, because initially it's just a button. So we need to kind of transition into our state where the form is open so we can type into the elements. So that's where Fire Event comes in. Fire Event is kind of your window into all of the events that a user could use to interact with the component in the browser. Fire event.click, fire event.change. There's like .scroll, .mouse wheel, most of the kinds of events that could happen in a browser, basically. To start with, we'll use click. So I want to click on this button and then get by text, add to do. So that should get us into the form state. And then we want to type in the name of the new to do and the select box. And unfortunately, we find that I have very conveniently forgotten to label this input, which means that it is hard to type into it here because there's not a like get by class name or a get by position in the code. You know, basically, if I want to type into an input, I need it to be labeled. So if I add a label here, add to do title, and then title. Get up there. Now I can change get by label text title. And then the second thing you're giving it is basically just a event that the onChange method would normally receive from a browser. In this case, we're just going to do a simple, like, basically we're doing something we can call e.target.value to get the new value of the title. So do that, write some tests. And then the same thing for our select box. Let's select, let's make John write the tests. What I call it, user. And then that's it. So we're just going to click on our add button. And then here's where we start to run into a little bit of a problem, because if we just run this test as it is, it's going to happily submit the add, which means it's going to call this function, and then it's going to make a request to our API. But our API probably doesn't exist in the testing environment, or at least we don't want to actually interact with it. So to do that, we're going to get into our first exercise with mocking. Jest makes mocking super easy, especially if you have kind of a split out helper like this, where it's exporting specific named functions that you might want to mock. Because I can just call jest.mock the path to the file, and then I can import PostJSON from API. The order of these doesn't actually matter, just magically puts all the mocks up at the top whenever it actually executes the test. So whichever way you want to do it. One gotcha, whenever you're mocking anything that you're going to have an expectation about, like when it's called, you usually want to clear it out between the tests, because otherwise if you write 3 tests in the same file, you'll end up with the same mock object in all 3 of them. And so if it's called by the first test, then it'll still be in a called state in the second test and the third test, even if those tests didn't correctly exercise it. So I'm going to use an after each and just clear the mock out. And then I also want my API to actually return the new to do. I don't just want it to return nothing, which is kind of the default for mocks. And so up here, I'm actually going to mock the implementation. And to do that, you just provided a function that then actually returns whatever you want your mocked method to return. And I am just going to cheat and copy the structure of it to do, because I don't remember all of the fields they have. There's that. And let's say it has a new ID and some tests. Its user ID is 2. It should be incomplete. There's that. So there we go. Now I can expect post.json to be called with what does my payload look like? Looks like this. So just copy that into here. Title. Some tests. User ID 2. Status incomplete. Let's see what that gives us. I've got my little watch process going over here. And we see, oh, the first mistake I made, post.json accepts 2 parameters, not 1. So it accepts, if we go look at it, the path and the payload, not just the payload. So I need to expect it to be called with do's and then the actual payload. And see what this gives us. Some warnings, we'll talk about these in just a sec. And user ID, not a number. What did I do there? Got my select. User ID on change.
When you pass my name, is my name just the visible and the value is the ID?
You are correct. Thank you.
Live coding, live debugging.
Yep. Sweet. So now we're passing, but we have this big ol' ugly warning here. I'll give you the TLDR of this warning because it's very confusing the way the docs word it. If your component does something asynchronous, if it uses async await, or if it uses promises or things like that, then by default, the test, when it executes your component, isn't going to wait for all of those promises to resolve. It's just going to run the test, make the expectations, and then the promises will finish up. It happens here that the test manages to finish before, like, the mock API returns fast enough that the test passes instead of it not having been called yet or whatever. But we can make our test more robust by having the test also await the result that we want it to, and then they'll guarantee that it's waited until all of the promises are resolved. To do this, we add another import from React testing library called wait for. And then we're actually going to make our whole test async because it has to await something. And then down here at our first expectation, await for that. So wait for basically will just try the thing, see if it happens. If not, wait, try it again up to, I think, like a 5-second timeout by default. And we have, ooh, a new error. Need a mutation observer polyfill. I'm surprised I didn't run into this earlier. Let's grab one of those on the fly. Oh, it is moved into, nope, that's useless.
Circular links.
Yeah, I don't think JS has that out of the box.
Interesting.
We've had.
I ran into this earlier. I swear I wrote some tests. Let's see what Stack Over GitHub says. JS 14. I don't know if I can upgrade. Sweet. Copy paste from Stack Overflow worked as always. So you can see our test is passing, and also we've gotten rid of the scary warnings that were flashing red and making us concerned. So that's a good start. Next thing we're going to do is test our to-do component. So we want to, let's see, we're rendering a checkbox, and we want to check it and then make sure that we get a update to our parent and an update to the API. So we're going to start kind of similarly. Checks the box. I already filled this stuff in, so that helps. Update to do. We need another just function. That is not a const. So there's that. And I already know this is going to make another API call, so I'm going to have to do this little song and dance again. I'm going to mock my API. And then this one does a patch, I believe. That's right, because it's an update, it's not a create. So I'm going to import patch. Remember to do my there, and then what are we doing with that? So it's just going to return it again, which means I can copy my thing from here, and it should be the same as the to-do, basically, just with the different status. So ID 1. Tests. It was incomplete, so now it's going to be complete, and the user ID is still 1. So I'm testing this one to demonstrate a different selector. We had get by text and get by label text for the form. This to-do checkbox is kind of tricky, though. It doesn't have a label. It doesn't have a text really that we can get because it's an icon. What it does have, though, is a role, which is another element that's supported by React testing library as a way to kind of get a handle on things. And so I'm actually going to use get by role here. And then I'm going to fire event.click, get by role checkbox, which should just check it. And then expect my patch JSON to be called with. This one is going to be to-dos and then the ID. So to-dos 1. Oops. And then it's going to be just this same payload structure, I think. Oh, no, actually, I guess it's just the status that we send to our API. So status is complete. And let's see how that goes. Oh yeah, we need our same Stack Overflow copy paste. Let's slap that up here. Sweet. So we've got that all passing, looking good. Just an example of a different selector, and a reminder to check the cheat sheet if you think you need something that's not text by label text. There's usually either a way to get at it or a way to make your component more accessible so that you can get at the element you need to get to. Next, we're going to put it together a little bit with a to-do list test. So we're originally going to make this, and well, actually, let's just make it an app test. Why not? So this is kind of getting into a bit more of what John was talking about with how React testing library tests can be full integration tests. where you can test kind of your whole application, or at least large subtrees of your application in conjunction, and make sure the whole thing is kind of fitting together in addition to just your individual components. And so I'm going to bring my wait for back in. I'm going to bring this back in before I forget. I'm just rendering my app. It just kind of renders. It doesn't need any props. My component, though, is going to call getJSON for to-dos and users. So I'm going to have to mock my API again. And I'm going to get that. And so this gets a little trickier because we're going to call getJSON twice, and we need to return different results depending on the input, which is how APIs tend to work, but is a little trickier from a mocking perspective. Clear our mock there. Fortunately, this function actually takes an argument or arguments, which are the arguments that were actually passed to your getJSON or to the actual function. So if we're calling for to-dos, then I'm going to return an array of to-dos, which I'm going to be lazy and copy paste. Let prettier do its magic. Else we're going to return some user. Prettier is literally magic. I don't know how it does that. All right, great. So we're going to, let's just do a quick sanity check, make sure things are all working. async, there we go. Learn about testing React. See if that passes. Wait for now. It used to be wait, and then they changed it to wait for reasons that I don't fully understand. So this is telling us our expectation failed. We did not find learn about testing React. But let's take a look. It helpfully prints out the DOM for us so we can see what we are getting here. So here's our to-dos. There's that. Oh, it's this emoji on the end. So get by text, a trick with it is that if you pass it a string, it'll only match if the entire contents of your DOM element are the string, which sometimes works okay, sometimes doesn't work so well. In this case, I could copy paste the emoji, but maybe there's like an icon or some other HTML element in there, and it's going to get kind of messy. Fortunately, get by text and all of the other finder methods also accepts a regex, and your regex can be pretty similar to your string, just with the slashes there. And if I do that, it's going to give me a fuzzier match, where as long as it contains learn about testing React, it'll still match even if I don't have my full emoji or my full contents there. And so you can see we're back to passing now. Seems like we're in good shape there. Let's try adding a to-do, because we want to test the full life cycle. We don't want to just, load and that's it. So kind of similar to our other test, we're going to, let's see, fire event.click, get by text, add to-do. That's what that is. I'll actually be a little lazy and copy paste the inputs from over here, because that's going to be the same deal. So integration test, user 1, label text, oops, that there. So then we are going to have our post.json called again, which is what it's complaining about here. And so we'll need to mock the implementation of that as well. So import that. And then after each, let's clear out both of these mocks. And then up here, let's mock our implementation by lazily copy pasting what we put over there. So there's one to do currently, so we'll say this one's going to get ID 2. write an integration test complete, and user was 1. So now we're gonna wait for get by text. We're gonna do write an integration test, because in theory, our cycle should complete, and then this text should be on the screen again as we've rendered the list of to-dos, and we've got our new one there. And look at that, we're passing. Let's take it, it's probably actually good for now. I think you kind of get the idea though. If you kind of look at this test and how it works, it's very similar to what a user actually does when they're dealing with your component. Ignoring the API mocks, obviously a user wouldn't mock the API, but they would be connected to Wi-Fi. Wait for the thing to load, then they're gonna click on the add button, then they're gonna find the title field and put in a title, they're gonna find the user field, put in a user, they're gonna click add, and then they're gonna expect to see their to-do on the list. And you'll notice that this has very little to do with the implementation of any of our components. Honestly, it really has very little to do with the fact that our components are even written in React, other than the very initial render. If you imagine a different render method that rendered an Angular component or rendered a Vue component or whatever else, all of the rest of our tests would be the same. It's just getting the initial rendered out to DOM kind of situation, which means these tests are extremely flexible and they're not going to break as you kind of refactor stuff. Because it just interacts with the DOM and with the elements that the user sees, which are the kind of the touchstones that should never change even as you go through more refactoring. But don't take my word for it. Let's just try refactoring a bit and see what we get here. So we have our to-do list, which is oddly a class-based component, even though the rest of our repository is hooks. Wonder why that is. Let's go ahead and turn it into a hooks-based list, and let's copy our render to start with, since that should be pretty much the same at the bottom. State, we have loaded to-dos and users, so let's get some use state, use sat. Use, users, set hiders. Great, that's copied. So component did mounts. That seems kind of like a use effect to me, because we want to run it once when our component mounts. So we will empty dependency array, because it should only run once. And then we are going to, this is a load data. There's a trick with async await and use effect, and I don't remember what it is, so I'm just going to use a Venable instead. Set to-dos, set users, users. That's there. Add to do, update to do. These look like callbacks, so we'll just copy them up here so that we can do that. So let's just set to-dos and our new to-dos array. And then to do there. Do this. Don't need the list.state. Need that there either. Clone our array. We have 2 more thises. Get rid of those. All right, let's see how I did. Sweet, test passed. Didn't have to touch it. That's kind of the holy grail, I guess, of the testing world, and when it comes to component tests, is not having to touch any of the test, I can just be confident that the user is going to get the same experience where they see the list of to-dos, click add, put in their information, get the same result. And it doesn't matter at all how my component is implemented, if it uses useState, if I have this promise, if I figured out how to use async and a use effect and did that instead. It's a nice boundary where, again, we're staying out of the implementation details and we're only testing like a user would test or would use it. So that's kind of the end of the talk. That's the steps I wanted to sort of run through building up to a grand integration test at the end. Are there any questions or thoughts or any other things people want to share before we kind of wrap up here?
I was just going to say I can 100% relate to the refactor you just did, because when we moved to pre-act testing library, I had a class component and then we migrated it to hooks and did not change, like the whole refactor should make all the tests pass still, because it was using pre-act testing library. The implementation details were not in the tests. So it was really just like, get this button, get that label, click this, click that. And so when I was speaking to the person that was doing the refactor, I said, like, 100% do not change the tests, because the tests are really what the results should be. And then after the refactor, like, there was a few hiccups, but then we've sorted those things out. The test just ended up passing. And so I think that's a good testament. And it's literally what you just showed to the library. I just think it's a great library as well. And I'm regurgitating what you said, but like the whole accessibility standpoint, like, oh, I can't test this. Oh, wait, what if I put a label? Then I can test it, So like people that aren't, I'm not an accessibility expert, but like I know some, but so like stuff like that, it kind of starts putting you in good patterns to like actually make your application better, even by just writing the tests. So it's, I don't know. Hats off to Kent. I don't think he ever sleeps, honestly. Yeah.
Yeah, he does a lot. He also has a bunch of courses on testing JavaScript if you want to go really, really deep on this stuff. But it definitely does create a virtuous cycle where the tests that are easy to write are tests that are pretty durable, because it doesn't give you anything more than the get by text, label text, etc. methods. And then the fact that it makes you use those methods means that you end up writing accessible components so that you can actually test them. So it kind of aligns all three incentives in a way that tends to produce, it makes it so the easy path or the happy path gets you to the best output, which is ideal for a framework and a tool.
Cool. I had a question. Do you have any? I assume the app is fairly large, ultimately. Do you have any maybe not like specific rules or guidelines, but like how far up the tree do you go with Jest and React Test Library tests? Like here in this is a very simple app, but like you can render the whole app, and have no problem. Have you run into any problems like running any walls or whatever, like going too far up the tree, like trying to render, like too many components or too, like the whole app when the app gets big?
Yeah. So I've never run into problems in terms of like, the library can't handle it because it's too many components or that sort of thing. The problems you tend to get are just that the farther you go up the tree, the more you have to do to get it to render. Usually the top level component has either a ton of props or a ton of like initializer API calls that you have to mock to get the initial data, or however it all gets in there, you got to do a lot of work. Whereas, these kind of leaf level components, I have to write like, 2 props or whatever to get it to work. There's a thing called the testing pyramid that's a common like Ruby on Rails ism, but kind of the principle behind it is if you think of your tests like a pyramid, the base is unit tests. You want to have a lot of those. They're fast, they're cheap. You can test all of the different use cases. Then as you kind of move up the tree, you get to like controller or request tests where you have to get a little more involved, pull in more of the application. You don't want to write as many of those as you do unit tests because they're not as well suited. There's a lot more overhead. And then at the top, you kind of get to full integration tests where there's like a Selenium, Cypress, Chrome driver kind of thing where you open a browser, click through it, you know, make expectations, that sort of thing. And I kind of think of the testing pyramid as applicable here as well, where for my individual components like add to do, you know, I might write 3 or 4 test cases for, I mean, in this case, it only really does one thing, but if there's multiple test cases, I might write 3 or 4 or 5 test cases for each kind of low level component. If I move farther up the tree, if I want to test a subtree, let's say I have like a sidebar and the sidebar is composed of, you know, 5 other components or whatever, I might write a couple of tests for like the major states for that. I'll usually try to write one top level integration test where I'm kind of rendering the complete application or the complete, like, you know, scope of the application for a certain screen or whatever. Just because it can be helpful to make sure like all the pieces are fitting together correctly, all the API calls, props, everything is kind of wired up. But then, you know, anything you would actually do with the application to interact with it or whatever is usually better served as a lower level test, either for like a tree, which I think of like a controller test, or at the component level for like a unit test. Obviously, it might vary a bit depending on the nature of your application. Ours, like the screen density is pretty complex. There's a lot of stuff going on. If it's like, you know, if it's a chat widget, for example, like Facebook Messenger, I could imagine like top level integration tests being a little more useful where the whole thing kind of is a component and you use it in its totality or not at all. But that's how I generally kind of think about approaching it though.
Nice. Yeah, we ran into some problems. Like I was rendering the entire app and, you know, mocking some stuff, and it was all working. But it was like Jess was like the tests were timing out. And there was a bunch of like async stuff we were waiting for. You know, there was some like a panel would slide out kind of situation, you know. But I'm pretty sure it was actually exposing some serious like performance problems with my app, you know,
Yeah.
ultimately. But I was just curious, like, you know, if you guys had any, since you're deep into using it, you know, any sort of times where you're just like, yeah, this is too much, like I'm moving over to Cypress or whatever, you know what I mean?
Yeah, I have occasionally run into cases where the default Jest timeout is too short because its default is 5 seconds, which is pretty unforgiving if you have any slowness or whatever. So sometimes I've had to increase the Jest timeout to 10 seconds or something to account for whatever's going on. But by and large, though, Jest is mostly pretty fast in and of itself. The problem tends to be more awaiting asynchronous stuff, and like if you have waterfall chains of asynchronous calls that have to resolve before the next one runs and that sort of thing, then that can add up sometimes.
Yeah, to touch on what Zach's saying, I mean, if you're mocking out the external boundaries like the network calls and stuff, that's where you get your latency. And if you're mocking that out, you should be okay normally in terms of like slowness, because like those calls should just kind of be like bang, bang, bang instead of however long the network call takes. But I haven't tested like full views in React testing library, but we're still kind of trying to I've used Cypress at other jobs, and so we're looking to still decide on an end-to-end testing library. They have some stuff in Rails with Capybara and stuff, but for people writing the test, it seems pretty cumbersome. So trying to hopefully move to Cypress, and then there is where we'll probably end up doing like really like the full test, like Zach was saying initially. We've been using Preact testing library more like integration tests for like this little chunk of whatever, and regular Jest tests for like utility functions, and then but I think the brunt of it will be really in the end-to-end tests for like critical workflows, you know, like log in, log out, basically whatever you deem really important in your application. But we're still trying to figure out which one to go with. I mean, I'm pro Cypress, but it's an open source project, so there's like a bit of debate still and stuff. So we'll see where it ends up. But
testing library has a Cypress package too. There's a Cypress testing library.
Yeah, no, there's that too. So you can get all the like get by label and all that. So there's that too. Yeah, I mean, I think Kent loves Cypress like big time. So it's in his testing course. So.
Does anybody else have any questions for Zach or?
I do.
Yeah, go ahead, Mike.
So, I've been always kind of critical of test right at the time it takes to write tests. I've been from small projects, one person to much larger teams, and I've only dabbled with Jest for basic tests, whether they're unit tests to mock data or to test complex logic. So, what value do you see in writing or testing full components like this?
Yeah, as opposed to like just not having tests, or as opposed to like
testing the mock data, the data from the API, or complex logic.
Oh, sure. The biggest benefit that I've seen to this kind of thing is just that it covers the most complete boundary of the code a user is going to exercise, where if you test all of your components in complete isolation without like APIs or anything like that, then each of your components will work in the abstract, but you might compose them incorrectly. Or you might have like, you're not rendering something where you think you're rendering it, or your component isn't actually making the API call you think it's supposed to make because there's some kind of logic error or that sort of thing. So mostly it's just getting it as close as possible. It's kind of the first philosophical principle I talked about the closer your code resembles what your user is going to see in the browser, or your test, I should say, the better the test is probably going to be at catching issues and being durable. And this sort of test is, very close to what a user is actually seeing in the browser because they, click, change things, do whatever, and then behind the scenes, the browser is making API calls and mocking responses. The other thing I would note is I think testing is kind of like, any habit like exercise or whatever, where it's not necessarily fun, especially compared to writing new code, because you're not writing something that does something, you're just writing insurance so that you don't, break it when your future self. But I've also noticed that the more I commit to writing tests and writing good tests, the faster I get at writing tests, and it makes it more fun because I can quickly express what I want and then feel confident that I've kind of covered myself against future regressions when me in 3 months forgets how the component is supposed to work together or whatever. And I think you kind of see that on the talk as well. Like, it took us 40 minutes or something to write all of the tests for this to-do list app, which is small and contrived, but, with talking along the way and everything. It doesn't have to be like a hours and hours of pain, I don't think.
I think part of my opinion comes from working in an agency. I've worked at 3 different agencies and I've never been in a internal role. So 9 times out of 10 clients don't want to pay the extra cost to write tests.
Yeah, that can definitely be tricky. I worked in an agency in the past, had something very similar. There was only one project where the client wanted to pay for tests, and it was because it was some kind of financial data that was being handled. I think that's almost more of a sociological question than a technical one of how do you convince a client that paying for tests is worth their time. I'm sure John can give you very many thoughts on that from his extensive experience with the same thing. But that definitely is tricky though, and it's relatively easier most of the time being on kind of a product team where you're maintaining the same product indefinitely, and you're going to be the person that's going to cause the regression in 6 months or a year and be disappointed that your past self didn't write more tests to help you out or whatever.
Yeah, I think just one more thing to add. I can talk all night about agency responsibilities, but the API related stuff specifically. So I think one of the perks that bringing in some managed and explicit mocking will allow you to do is to actually think about more than the happy case, which I think we are all really, really bad at as developers. So to be able to make sure that your components can handle things like failed network requests and handle them properly and handle them at the level that they need to be handled. And, if your API is working properly, you're not always going to see what happens when things time out or the server falls off or the database doesn't start or different things like that. But you can handle that at the UI level where your responsibility is actually to present information to the user to like help them through that situation, or to not just let it all kind of show a giant white screen. because the JavaScript crashed.
I guess you work in PHP if you've seen a white screen.
It happens all. Hey, I mean, JavaScript ecosystem loves their single page apps, and there ain't nothing there if JavaScript's not running. So
PHP.
oh, they all.
Any other questions or thoughts from anyone?
I just wanted to say thanks for the talk. It was really great.
Yeah, good job, Zach.
Yeah, sure thing.
Agreed.
And I'll commit this code also and push it up to GitHub and figure out a prettier version of this so I don't embarrass myself. And you can reference it there as well if you want to look back at anything we talked through here.
Yeah, you can just jam that into setup.test.js and you won't have to look at it again. I think
Fair enough.
The other thing was to, the problem is you're using CRA, right? Like you're using Create React App here. And the ultimate thing is the version of just DOM or something that bundles with it is old, I think. And so you can install the new version, and then you have to add something to your package to like to the script that starts up just to pick the right environment or something like that. So that's what we ended up doing, but I could copy and paste some code too, but I can't really explain it much more past that. But yeah, we ran into that too. All right, cool. Well, Zach, I mean, if you know anything more to add, if nobody else has any more questions, then I would say thanks again to Zach for running us through this. We really appreciate it. We're going to try, I was saying before, we took a little kind of break over summer, and we're going to kind of try to get some more regular events going. So I think I'm planning on our next event being Cypress related. I am trying to decide if that's going to be next month, or if next month we might try to do some sort of Hacktoberfest related thing or not. So we're still in discussions about that, but keep your eyes out on the meetup email feed, the Twitter account, on Slack. We will be communicating with everybody about our plans as they get, planned. But other than that, everybody have a good night. Thanks again for coming, and we will see all of you soon.
Thanks, everyone. See you.
Have fun in St. Louis, Zach.
Take care, everybody.
Bye.
Bye, everyone.
Thank you. Thank you.